Hello everyone. In this video, we will learn how to parameterize a circle or in general ellipse. Well, let us just recall that circle of radius r centered at the point AB, the equation for this guy in the Cartesian coordinate is x minus a squared plus y minus b squared equals to r squared. In other words, the distance of xy from AB must be constant, r. Yes, that's what it says. But now I want to parameterize this. This is an equation there. So let's just work with the unit circle centered at the origin. In that case, well, you may say that, okay, the equation for that one is x squared plus y squared equals to 1. You may say that, okay, I want to use the idea that we had before, write y as a function of x and set x to be our parameters. But when you're trying to write y as a function of x, you have to choose either plus or the minus side. In other words, you can only consider either upper semicircle or lower semicircle. Yeah? So for that, then yeah, you are right. We can go ahead and set x to be the parameter, y to be 1 minus squared. And here it's enough t to be between -1 and 1. This idea won't be able to get us the one-shot parametrization. And the reason is very simple, because this idea works when you have the graph of a function. But circle is not the graph of a function, simply because it fails the vertical line test. So we need a new idea here. Instead of going and parameterizing circle by x, we can use another parameterization. And that parameterization is what we have been using, but if you look carefully, instead of working with x-axis, you can go ahead and use the angle. This way, basically, when angle is between 0 and 2 pi, you go around the circle counterclockwise, starting from 1 and 0 once. Yeah. And what is the parameterization then there? So here, this is cosine t, while the x coordinate is sine t. Yes. And if the radius is r, in that case, you have to multiply these guys by r. So this is the right parameterization. So I will write it here. The circle centered at the origin with radius r is given by this parameterization. X is equal to r cosine t, y is equal to r sine t. And this is enough t going from 0 to 2 pi. Okay, go around once, starting from 0, 1, 0, and then go around. But what will happen if we are interested in going around, the circle not centered at origin, in general, at point AB? Well, for that, what you need to remember is that this is enough to shift the circle to a B, or I mean the center of the circle. Here, this will be done by adding a to x coordinates. So a plus r cosine t, and then y equals to b plus r sine t. This goes, again, t goes from 0 to 2 pi. And if you want to see why, this, at least you have to do this work once. So you want to show how x minus a squared plus y minus b squared is equal to r squared. So let's see. Here I have a plus, I'm using this one for that, r cosine t, that's x minus a squared, plus b plus r sine t, minus b, that was y minus b squared. This is equal to, this cancels with that, and we get r squared cosine squared t. This cancels with that, we get r squared sine squared t. If you factor out r squared, this is our friend. Sine squared plus cosine squared is equal to 1. So you multiply that by r squared. What we showed is that x minus a squared plus y minus b squared is equal to r squared. Okay, so that gives us the general standard parametrization for our circle. But the important thing is that, remark, we have other parametrizations. This is just one of many parametrization for the circle. For example, I'm just working with the unit center, that origin. I can start x from r cosine of, instead of going t, I can add any number there, any theta there. Okay, so y is r cosine t plus, okay, this must be sine t plus theta. In this case, the parametrization is, again, t goes between 0 and 2 pi, and this parametrization will work, and this theta is constant there, but the difference is that this time it will start from the theta. This will be for t equal to 0 and move counterclockwise. Or you can have x equal to r. Actually, you can have sine t and y equal to r cosine t. And well, again, this will be the circle. This will parameterize the circle. The difference here is that, and this is nice to follow at least once, this time for t equal to 0, we are working at this point here, and then as t increases, x increases, so this will go clockwise from this point, the highest point, and clockwise and come back at 2 pi back to that point. There are other things. For example, another version is that you go x equal to r cosine lambda t, y equal to r sine lambda t. And in that case, If lambda is positive, this goes counterclockwise, starting from 1, 0. It will go like that from t equal to 0 here. This is for lambda positive. But the point is that this will go with different speeds. So actually your t in this case, it doesn't need to go up to 2 pi. It's up to 2 pi over lambda. Okay. Or if lambda is negative, this will start from the 1, 0, but it will go clockwise, and the direction will be different in that case. So all these ones are different parameterization. The standard one, which is the important one, you have to keep in mind, which is this one, and the parameter is enough to go up to 2 pi. If you go beyond 2 pi, it will still give you circle, but you're basically going over circle again and again. Okay. Well, let me finish the video. How about ellipse? How about an ellipse? Well, when you're working with ellipse, you have to know the equation. What is the equation for this guy? Paste. This is circle. Now I will go and choose the circle and make it like ellipse. Okay, I'm making it a little bit smaller. Okay, this is nice. Yes. So if the ellipse has the x radius is r1 and y radius is r2, and the center is in general AB, let me write the most general case, AB, then remember that the parametrization for or the Cartesian coordinates for this one will be x minus a divided by r1 squared plus y minus b divided by r2 squared is equal to 1. And when r1 is equal to r2, this will give you the equation for circle. So the parametrization for this one, I will challenge you to try to figure out this one yourself, or at least check this one. This will be a plus r1 cosine t, and y is going to be b plus r2 sine t, and t goes from 0 to 2 pi. And that's enough. I believe now you can actually confirm that this gives you these points, and well, the other remarks also apply for ellipse or parametrization of